All right, so today we're going to look at kind of radicals day two, and what we're going to look at today is the almost like the collection of like terms, right? So we can add and subtract radicals of that have the same radicand, right? And so what we're going to try and do today is take the skills from yesterday in simplifying radicals individually, and then what we're going to find is say something like root 6 plus 2 root 6 would actually be like 3 root 6s because I can collect them like terms. Okay, and so that's going to be the premise today, and we're just going to build off of yesterday's skills writing radicals in their simplest form. Okay, so we would have seen yesterday a bunch of questions around simplifying radicals. And the more of these you do, you start to get the hang of like root 12 you should recognize as being root 4 times root 3, right? So if I took this and I said root 4 multiplied by root 3, I can then add the root of 50 is going to be root 25. Sorry, I'll make that neater. Root 25 multiplied by root 2. Okay, it's just a reminder that the square rootable radical, I usually write first so that they turn into a coefficient, right? And then we're going to take away root 48, which could be simplified as root 16 times root 3. And then we're going to add root 18, which could be simplified as root 9 times root 2. Okay, what we're going to see here, I'm just going to rewrite the line. I'm going to get 2 root 3 plus 5 root 2 minus 4 root 3 plus 3 root 2. Okay, and then so, as I alluded to, you should have what we call like common radicands, right, if you will. Let's see how the blue turns out. You're going to see that, and then you're going to see this with that. And we're collecting like terms is essentially what we're doing, right? And so what I can do is just group 2 root 3 minus 4 root 3s plus 5 root 2 plus 3 root 2, right? And so we're going to get negative 2 root 3 plus 8 root 2. Okay? That'd be your answer here. Fully simplified. Okay, so that's all we're doing over the course of this lesson is just basically just going to do some questions with some binomial expansion mixed in and collection of like terms, I think is the highlight of this lesson. So all I'm going to do is just take you through these questions and hopefully you just solidify some of the skills that we've been working on since yesterday. Okay, so for root 18, okay, again, the more of these questions you do, you start to recognize the radicals and the radicand specifically underneath, right? And so 4 times root 9 times root 2 minus 2, the square root of 63 could be broken up as the square root of 9 times the square root of 7 plus 175 can be 25 and 7. Okay, and then plus 5, the square root of 98 can be broken up into 49 and 2. Okay, so square root of 49 times the square root of 2. And we're just going to clean up all these radicals and basically square root the ones that can be square rooted, right? And so we're going to get 4 times 3 times root 2 minus 2 times 3 times root 7 plus 5 times root 7 plus 5 times 7 times root 2. So we get 12 root 2s minus 6 root 7s plus 5 root 7s plus 35 root 2s. Okay, then we just collect all the like terms basically. Okay, 12 root 2. Again, you might not necessarily need to do this step, but just in case, there's some funny signs going on, I like rewriting them. And now you can add them. So 12 root 2 plus 35. So 12 plus 35 is going to be 47 root 2s. Negative 6 plus 5 is going to be minus 1 root 7. Okay, and that's it. Okay, it's just, again, we're seeing skills arise from grade 10 directly and indirectly. Okay, this concept of collecting like terms has been around for a couple years now, okay, grade 9 and 10, but we're seeing it in different situations that are not involving just x's and y's anymore, okay? So again, we're just trying to reinforce this idea of building the building blocks, right? And so just take that lens, right, of we're just trying to re-solidify some skills. Okay, so again, here's a grade 10 skill. This idea, and grade 9 for that matter, expansion. This one's a little bit more grade 10. Okay, and in B, sorry. Okay, so what we're going to do is we can take coefficients multiplied by coefficients, and like if it would have been a variable times a variable, right? But in this case, it's a radical times a radical. So we're going to get, when I expand this out, I'm going to get 6. Root 3 times 15 is going to be root 45 plus 3 root 18. Okay, and so if I were to simplify the root 45, I would arrive at 6 root 9 times root 5 plus 3 times root 9 times root 2. Okay, so I get 6 times 3 times root 5 plus 3 times 3 times root 2. Okay, and then we're going to go, okay, that's 18 root 5 plus 9 root 2. If you really wanted to, it said simplify, so I think what we could do is factor out the 9 and write it as like this. It'd be 2 root 5 plus root 2. It said simplify. So that's, to me, fully simplified. Okay. So again, if we move on to B here, this is FOIL, if you recall. Okay, it's first outers, inners, lasts. Okay, you could also use the box method, or you could use this distributive pattern like I've been showing, like I drew in the last question. The exception that 3 root 2 times root 2, 3 root 2 times negative 5 root 3. That takes care of the first two, but this still is also multiplied by both. Okay, so you see four things in your expansion. There are 4 multiplying, you're multiplying 4 things together. Okay, so in the next line here, we're going to see 3 root 2 times root 2. 3 root 2 times root 2 should be 3 times 2, because root 2 times root 2 is just 2. Then we're going to take away 15 root 6 and add 4, this is now I'm on this arch here, okay, 4 root 6, and then the last arch is going to be minus 20 times 3, okay, because again, root 3 times root 3 is going to be just 3. So we get 6 minus root 6 is root 6, 15 root 6 plus 4 root 6 minus 60. Okay, so we could group this together. We could go negative 15 plus 4 is going to be negative 11 root 6, and then 60 take away 60 is going to be minus 54. Okay, and that's your answer there. nothing to be factored out, or you can't simplify root 6, so that's it. Okay. On to these next ones. They're all just going to be little derivations of things that we've worked on. Okay, so this one here, again, we're learning about this idea of x squared is equal to x times x. And so I could just this idea of repeated multiplication. Okay, and so what I'm going to get here, 2 root 2 minus root 7 multiplied by 2 root 2 minus root 7. Okay, and we expand. So we actually get 4 times 2 on the first multiplying, right? 4 times 2 minus 2 root 14 minus 2 root 14. That'd be from the next arch. Okay. And then the last one, it'd be plus 7. Because negative root 7 times negative root 7 is positive 7. So we get 8 minus, we could probably do this in one line, and we can combine those if you want. So that's minus 4 root 14. Okay. And then plus 7. So we get 8. We can just have negative 4 root 14, 8, and 7 should be plus 15. Okay. Okay. Let's do the next one. Okay, there's lots of repetition in here. Actually, maybe I'll leave that one to you to do. Okay, and we can jump down to. I'll do it. It's a little bit different. Okay, 2 root 3 times root 2 root 3 is going to be 4 times 3. Right, root 3 and root 3 is 3, minus 2 root 6 plus 2 root 6, and then minus 2. Okay, so these are those zero pair out, and we're left with 12 minus 2, which is going to equal 10. Okay, for that question, that was easy enough. Okay. Down we come. So what we're going to see now, we have radicals with division in them, okay? And there's one component here where we don't like having radicals in the denominator. That's what we're going to look at in question C there. So we're going to basically multiply by root 3 over root 3, okay? I'll get to that in a minute. But for now, there's definitely, when you see a fraction, especially with a number like 10, I think we're going to have some reduction to do there, okay? To get rid of, or make the denominator smaller, if you will. But the first thing we're going to deal with is that radical on the top, that root 125, right? So what we can write that as is 15 minus, that's going to be the square root of 25 times the square root of 5 over 10. Okay, and we're going to see here 15 minus 5 root 5 over 10. I can factor a 5 out in the numerator. And we're going to be left with 3 minus root 2 over 10, which then the 5 and the 10 reduce to 1/2. Right? So we get 3 minus root 2 over 2 is our answer. Okay, if I move on to the next one, the way I could reduce the radical in the numerator as 4 minus root 4 times root 2 over 4. And we're going to get 4 minus 2 root 2 over 4. Same thing. Factor a 2 out. We get 2 times 2 minus root 2 over 4. And the 2 and 4 reduce to be 2 minus root 2 over 2. Okay? Last one. Now, we don't like having radicals in the denominator. We've seen a number of times where I can take something and multiply it by, itself, basically, particularly with the radical, and it spits out just a number, right? So if I multiplied, And I can't just selectively do that in the denominator, right? So if you look at this piece as a whole, that's the same thing as multiplying by 1, which is how we get away with this, okay? So what we're going to do is we're going to end up with 2 root 3 in the numerator over 3 times 3, because the root 3 times root 3 is going to turn into 3. So we get 2 root 3 by 9. Okay, and that can't be simplified any further. Okay, so hopefully that just reinforces some of the skills that we've been working on since yesterday. And definitely by the time you finish the homework questions today, I just picked arbitrarily ACE. You can pick whatever you want to do, to really, like whatever you find interesting, or questions that you think you're going to struggle with. But that's it. That's us dealing with radicals, and where this is going to become useful is when we start solving for roots for quadratics, right? Solutions or x-intercepts, okay, which is what we're going to start tomorrow, okay? And so it's handy to not have to write down something like, you know, the square root of, let's say, one of the early questions, square root of 50, right? Like I can take the square root of 50 now, whereas before I might not have necessarily had an idea. I can take the square root of 50 and write it as 5 root 2, which we learned in the first question, okay? Square root of 2 is about 1.4, and so if we take 5 times 1.4, we get a better idea of what our answer might actually be, versus, you know, I don't know what the square root of 50 is off the top of my head, or even have a ballpark of it, right? We'll get close, but not great, okay? So, again, makes our life easier, tools to deal with things that complicate our lives at times, okay? Especially without having a calculator, let's say, okay? So that's that. Try those homework questions, see what you get.